Howdy, it's Mr. Russell, and we're here to talk about the properties of matter, specifically the physical chemical changes and the physical and chemical properties. So we'll start by taking a look at a video of this guy. He's demonstrated some good properties of it.
Okay, we're going to talk about the difference between physical and chemical properties. Physical properties are properties that you can observe about something without changing it. Look at this piece of paper. It's rectangular shape. It is flat and it's white. We didn't change it by noticing that. There are two different types of physical properties. There are those that are within the paper. They're called intrinsic properties, and there are those that are outside of the paper. Now here's what that means. Within the paper, it's white. If I take this piece of paper and I tear it, that piece is still white, it's still flat, it's still a piece of paper. Extrinsic properties are properties of measurement. They're outside of the paper. How much you have of the paper changes those properties. For example, it's this long by this long. If I take the piece of paper and I tear it, I've changed the extrinsic properties of it. Another physical property that people sometimes confuse to be a chemical property is magnetism. This magnet is magnetic. These clippers are made out of metal. Now I haven't changed them. Magnetism is a physical property because I didn't change these things. They're still the same. Chemical properties are properties of a substance that describe its ability to change or its ability to combine with other elements and become something new. The most common physical property that we talk about is flammability. If I take this white piece of paper and I put it to the flame, now it's combining with the elements in the room, in the air, and it's turning into something new. You can see that it's changing color, it's giving off smoke. You can see the flame. It's becoming something brand new. That's a chemical property. Hope that helped.
All right, so we saw a couple of very good things here about how he's taking care of explain the intensive and extensive properties. Now he called them intrinsic and extrinsic. We call them intensive and extensive. So that's the only difference. But he does a really good job there. He also did a very good job of showing you exactly what to do in case you light something on fire by accident in my lab. Put it in the sink and turn the sink on. That's a very easy way to take care of that. So that has happened before, so I've always told students to just throw it in the sink. Alright, so let's take a look at the physical properties. A physical property is a quality that describes only that substance. Alright, and so an example could be color, density, hardness, or temperature. I wonder why density is highlighted. Maybe I need to remember that one. A chemical property is a quality that describes how a substance interacts with another substance. Okay, so that physical property is describing describing the substance and only the substance. But a chemical property is describing how the substance reacts with another substance. Okay, there's two substances required here. So the rusting is one, combustion or flammability is one. Now, electronegativity is another thing we'll talk about later in the year, but that's how well it will bond with another element or another compound. So let's check for your understanding. I'll pause and wait while you guys fill these in. All right, welcome back. Hopefully you have done these and you've seen that the color is physical, brittle is physical. Brittle means that describes how well it falls apart. Soluble is physical. Flammable is chemical. Mass is physical. Now reacting with acid is chemical. Melting point is physical. Temperature is physical. Toxicity is chemical. And then corrosiveness is chemical. All right. So now, if we take a look at those physical properties, right? Physical properties can be intensive properties and extensive properties. So let me make that a little bit more clear. Physical properties, these properties can break down into two more categories, intensive and extensive. All right. So physical properties break down into two extra categories. The intensive property is a physical property of a system that does not depend on the sample size. So it does not depend on the sample size like that density one. That in our density lab, all those pieces of zinc should have had the same density. All the pieces of wood should have had the same density. Temperature, melting point, specific heat capacity, or color. If you cut them in half, you'll still have the same amount. Okay? Now, if you have an extensive property, it depends on the size of depends on the amount. So extensive properties depend on the amount, or they depend on the mass. It's kind of like mass or volume, enthalpy, or your heat. It depends on how much quantity you have there. So let's check for our understanding here. All right, hopefully you got these. Surface area, it will be an extensive property, because if we cut a substance or cut the object in half, the surface area will change. So that will be an extensive property. Let's see. Density is an intensive property. I must stress that. Now, a physical change, let's talk about those two different changes. A physical change is a change that doesn't actually change the actual substance. It's frequently a phase change, something like freezing, melting, boiling, evaporation, sublimation, deposition, all those good ones. All those phase changes are physical changes. Now, if something dissolves, you are not actually changing the substance. You are just separating the ions, kind of like you're separating a piece of paper. Those ions are still there, and they're not chemically bonded with anything else. And then if you change the shape, then that's a physical change. Sublimation is a good example. That's with dry ice. Whenever it sublimes or moves from a gas to a solid to a gas, it changes its state. When water boils, it's also a phase change. Salt dissolving is a physical change. And then some thermal pollution also is a physical change. Now, a chemical change is going to be some kind of chemical reaction. So things are breaking down and forming new substances. You're forming some products. You're seeing a chemical reaction here. So rusting or photosynthesis or cellular respiration, remember biology, digestion, combustion, those are all chemical changes. So in a chemical change, there are some clues that you can look for. All right. Now look for an energy change. If there's a change in energy, then it's a chemical change, because that means a chemical reaction has happened. If there's a change in color or odor, then a chemical change. Or if there is production of a gas, or maybe a precipitate has formed, a solid has formed, then that's a chemical change. Or if it's easily reversible, and these guys are not easily reversible, you would have to do another chemical reaction to change it back. So if we take a look at iron, all of these iron things that are sitting out, over on the ocean, all the docks right there, they start to turn orange. That's because the iron is reacting with all the seawater, and it's reacting with the oxygen. And so that seawater speeds it up, and it just corrodes it. And so that iron turns into iron oxide. Iron combines with oxygen to make iron oxide. Just like these old cars here. Photosynthesis, where carbon dioxide and water are used to drive and sunlight is used to drive the chemical reaction to produce oxygen and glucose from a plant. Right? You learned about that one in biology. And then digestion of food. Carbohydrates are turned into glucose. Proteins are turned into amino acids. And then lipids are turned into fatty acids. Right? all that stuff from biology. Combustion of a gas, kind of like cellular respiration, where you have a hydrocarbon reacting with oxygen to produce carbon dioxide and water. So go ahead and check your understanding here. I'll wait for you. All right. Hopefully you got everything. Dissolving, remember, is a physical change. And cutting something is a physical change. And cooking is always a chemical change. All right, that's going to be it. I want y'all to have a great day.